Welcome to Chemistry Wide. Today we will see LS coupling or Russell-Sander coupling constant. If take the one atom, see the structure of atom. This is center of nucleus. This dot is electron rotating the own path. These symbols denotes the electrons moving on the orbitals in atom. See, first one, in structure of atom, the nucleus is at center, their subshell in electrons are moving around it. Second one, the moving the electron having angular momentum. There, the electrons also spins around its own axis. So, electron having spin orbital angular momentum. Next, the orbital angular momentum denoted by L and spin angular momentum denoted by S. So, here L will be L1, S will be S1. The case is only for one electron, but if we take an multi-electron, see the structure like this. This is the multi-electron atom. Next, there are more electrons. So, each electrons will have orbital angular momentum and spin angular momentum. So, here orbital angular momentum L may be L1 or L2 or L3 or L4, so on. Next, the spin angular momentum S may be S1, S2, S3, S4, so on. The total resultant of the orbital angular momentum and the spin angular momentum, it is called J. J is coupling constant or resultant angular momentum. Now, we will see the term symbol. For example, term symbol, this is the formula for term symbol. See, 2s plus 1 Lj, here 2s plus 1 is multiplicity of energy state. Energy state means orbital states like first orbital, second orbital, like this. Next, L is the total orbital angular momentum. J is the resultant angular momentum. So, L plus J. Here L is maybe S, P, D, F orbitals. So, L equal to S, P, D, F. At S orbital 0, at P orbital 1, at D orbital 2, at F orbital 3. In order to term symbol will follow below the steps. See the steps. Step 1, determine total orbital angular momentum. How is determine angular momentum? So, it is getting by the vectorial combination of different orbital angular momentum of the electrons. So, here L equal L plus 1 L2, L1, L plus L2 minus 1, L1 minus L2, so on. Let us consider the energy state below like this. P2, it means p orbital. This is the p orbital. There is 2 electrons like this. See the structure. At first +1, at second energy state 0, at third energy state -1. Here 2 electrons, first electron in +1 orbital and second electron, this is first electron, this is second electron, in 0 electron orbitals. So L1 will be 1, L1 equal to 1, L2 will be 0, L2 equal to 0, L2 equal to 0. So L1 equal to 1, L2 equal to 0. Here L will be 1 plus 0 or 1 minus 1. So equal to 1 p 0 s. This is the s orbital, this is 0. At p orbital this is 1. So totally equal to p equal to 1 and s equal to 0. Step 2, determine total spin angular momentum. It is getting by the vectorial combination of different orbital spin angular momentum of the electrons. So here it is denoted, spin angular momentum is, it is denoted by s. Here s equal to s1 plus s2, s1 plus s2 minus 1, s1 minus s2. This is the formula for this second steps. Let's consider the energy state P2 below. First energy state +1 and second energy state 0, third energy state is -1. Here 2 electrons, both are same spin. This is both the same spin, means same direction spin. So s1 equal to plus 1 by 2, s2 equal to plus 1 by 2. So vectorial combination will be form s equal to 1 by 2 plus 1 by 2, 1 by 2 plus 1 by 2 minus 1, 1 by 2 minus 1 by 2. Here we got two spin energy states, that is 1 and 0. Step 3, determine total angular momentum. The vectorial combination of L and S. So J is the coupling constant. So J will be L plus 1 or L plus S minus 1 or L plus S minus 2. L minus S. Example, carbon atom. If take carbon atom, its atomic number is 6 and electronic configuration is 1s2, 2s2, 2p2. This is the +1 at first energy state, 0 at second energy state. Here L value is L1 equal to +1, L2 equal to 0, L equal to 1 plus 0 equal 1. So L equal to 1. So S value is S1 equal to plus of, S2 equal to plus of, S equal to half plus of equal to 1. So J values we got, J equal to 1 plus 1 and 1 plus 1 minus 1 and 1 minus 1. So j value will be j equal to or 1 or 0, and it is term symbol 2s plus lj. So we get three values here, that is 3p2, 3p1 and 3p0. Here ground state term is 3p0. So j value is become j equal 1 plus 1, 1 plus 1 minus 1 minus 1. In this case j value will be j equal to 2 or 1 or 0. The term symbol, atomic term symbol equal to s plus 1j. So we got 3p2, 3p1, 3p0. Here 3p0 is a ground state term. Step 4. Condition for the determining ground state term. See here, see note. This is the condition for here. The ground state term is 1 with maximum spin multiplicity or maximum number of unpaired electron. It is shows the number of the unpaired electron is maximum. For example, here 3 states are like 2p, 1p, 3p0. Here 3p is maximum spin multiplicity and it is will be the ground state term. Ground state STATE. I did not mention E, sorry. Ground state term. Next, step 5. If there are more than one term with the same multiplicity, the ground state term will be one with the largest L value. Example, here 2 terms like 2p, 2d. Here 2d will be the ground state term. For half-filled or less than half-filled shell, the ground state term is 1 with the lowest j values. For example, carbon atom, see carbon atom at the first energy state, this is second energy state. Here 3p2, 3p, 3p0. So there are 2 electrons, so it is less than half filled, and there are 3 terms 3p2, 3p, 3p0. Here ground state term is 3p0. For more than half filled state, the ground state term is 1 with highest j values. For example, oxygen atom. See the oxygen atom. This is opposite spin. These both are unpaired electron. This box is paired electron. The oxygen is 4 electron. It is more than half filled and it is 3 states, that is below 3p2, 3p1, 3p0 at p orbitals. Oxygen is at p orbitals, this structure. Here the highest value is 3p2, it is the ground state term. See here the highest value is 3p2, this is 3p2, it is the ground state term, this one is the ground state term. Thanking you all, please subscribe the channel. More videos on the way. Have a nice day.